Yes. Okay.
What I want to do, now that we've gotten pretty decent at like displaying data in graphical form, I want to talk about how we can actually start crunching the data. And there's 3 stops that I want to make along that way. One of them we're going to start today, one will start on Thursday, and one will start probably next week at some point. But what I want to talk about today are how to measure what I call center. Center of data. And there are a bazillion ways to measure what's called the center of a data set. The big idea of center, speaking of centered, the big idea of center, did it just fall? The big idea of center is to take a wide-ranging set of data and use one number to stand for it. And that one of the most important numbers that we use is what? We've used it like 12 or 16 times today in discussion.
Average.
The average of a data set. Zero is sometimes one of the data sets, sometimes not. But the average is going to be a measure of that center. So I'm going to make a little laundry list at the board. Ooh, there's a chair there. The average, which is also sometimes called the mean. But what is the average? What is the average of a data set? If you had to summarize it right now, what would you say the average is?
The sum of a set of data.
Most frequently used data point? Yeah, that is how it's used sometimes. Exactly. Kate, go ahead. Oh, it was, wait, Hattie? Okay, good.
The sum of a data divided by the number.
Okay, your formula, sum of data divided by, good, I like that very much. We got most frequently occurring, sum of data divided by, good. Other things that come to mind when you hear the word average. Fair share, love that. Fair share, good. Other things that come to mind. All right, do me a favor. I need 10 people up here. 10 people. 10 volunteers. It involves sugar. That might go. There we go. Now they go. There we go. 10 people. All right, Andrew, here you go. Don't consume these yet. Yes. There we go. Go. Natalie, awesome. And how we do? Is that 10? That looks like 10, doesn't it? Here we go. Oh my goodness. Just jump in line. All right, we got 10. We should have 10 if I counted correctly today. I didn't count. I need one more. Thank you. What's up, your name? Michael. Michael, thank you. All right, there's 10 people. Here's what I want you to tell me. Pull this back a little bit. Old school Zoom. There we go. Remember how I told you guys on the first day of class? Don't worry, I'll never video record you. Yep. Just kidding. So here's what I want. I've given everybody up there some lollipops. Some might mean 0. Sorry. What I want to know, on average, how many lollipops does a person standing at the front of the room have? But you're not allowed to use Hattie's formula that she quoted earlier. Remember what Hattie said? She said add them all up and divide by how many there are. You can't use that. But I still want to have the number of how many lollipops per person the 10 of you all are averaging. So everybody, 10 up front and also 15 or so sitting back here by me. How are we going to do that without using the formula that you guys have grown so accustomed to? What do we think?
Kind of the individual popsicles that each person has are lollipops.
So right now, like so you've got like say 7 Andrew and Skylar has maybe 2 or 3.
6.
Okay, and then do what with that?
And then kind of look at your data set and then see what the most recurring number is.
Oh, okay, let's do that. So there's 2 zeros, correct? 2 of you have none. Anybody have 1? We got 1. 2s? We got a 2, so we have 2 zeros, a 1, a 2. Got some 3s? We got 3, we got 1 3. So we got 2 zeros, 1 1, 1 2, 1 3. 4s? Couple 4s? 5s? 2 5s? 6s? 6? Anybody above 6? Okay, we got 4. So we got like 2 of a lot of things, like 2 zeros, 2 4s, I think, 2 6s, 2 5s. Okay, Andrew, what do we do with it? I love it. What do we do with it?
Okay. So now.
If we group them together.
In what way? Tell me more,
So
JC.
there's like 2 zeros, so they stand next to each other.
Oh, good. Let's do that. Get in line, you guys. Get in line so the people that have the same numbers are with each other. We're going to make a physical histogram. Remember how proud I was earlier and earlier again? I'm even prouder now. Where are my zeros? My zeros are down there. Can you guys stand in back and in front of each other? So come like out from the board, make that the second dimension. So you guys that have zeros stand in front of each other. Yeah, we're making a histogram. Making a studentagram. Look at that. 0, 1, 2, 3, 4, 5, 6. Did anybody have 7? Nobody had 7? So 0 through 6. That is gorgeous. Look at that. COCC, a bobcatagram. Yes. Yes. Now what do we do? We dance? What do we do now? I love this idea. It looks like a bell curve. Well, it's... Who said that? I love that idea. Jenny, was that you? It could look like a bell curve if I gave you more than 10 data points. The problem is I'm a bastard and I didn't. If I had given you more, of a representative sample, you may actually get a bell curve out there, but I didn't. Because I wanted to use 10, because 10 is an easy number to compute with. So, what are we thinking?
So instead of like counting them up, like physically, 1, 2, 3, 4.
Yeah?
Can you, I don't know if this is like the same thing, like cross them off like on either side until you get to the middle?
I love that. That's what's called the median, JC. That's another measure of center. No, you guys have hit all 3 that I want to talk about today. There are literally probably a dozen measures of center. There's one called the mid-range, there's a harmonic mean, a geometric mean. You guys have hit the 3 I care about. Jenny, you said the most occurring? That's technically called the mode. And we'll talk about that. We'll chit-chat about that in a little bit. The median, what you just described, chop, 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 chop. Because what would the median be? If we chop off 6 and 2 zeros and a 5 and then a 5 and the 1 and the 2 and the 4 and the 4, then we get down to Natalie, I think, is Natalie and JC, you guys are like the middle 2. Okay, so you go with like 3.5 or something like that. Yeah, that's the median. But I'm trying to get it what the true, the literal arithmetic mean or average is. Good, hold that thought, JC. Give me like 5 minutes. Good, good. Other ideas. I want you to think about what Skylar said earlier. What did you say? We haven't hit back on what you said yet.
Fair share.
She said a fair share. An average is, what did you mean by that, Skylar?
So, can we take these apart?
Yes, you can, of course. That was only, take your bands off those lollipops, friends.
So, if I have 5 and plus 3, I have 0.
So Skylar's going to give 1 to Natalie.
We each have 4.
Now you each have 4.
We have a fair share, but we need to do that with an average.
Did everybody hear? Thank you, Skylar. That was brilliant. Not that everything you guys have set up there has been brilliant because you've hit every single measure. But this is the definition of what an average really is. It ensures a fair share amongst all those present. So, what's the fair share of all you guys? Remember these guys at the end don't have anything. Remember these guys at the end with nothing. Go ahead. And those of you guys that are watching this unfold, notice what they're not doing. What are they not doing right now? Hold that thought, Kate. Give me 2 minutes. What are they not doing to figure this number out? They're not adding them up, are they? They're not adding them up. They're just figuring out. Oh, huh. Now we're going to see how well I count at 1:04 a.m. when I set this whole thing up.
1%.
Huh. Well, I'll be damned. Everybody up there now has,
3.
which means the average number of lollipops per person up there is 3. Fair share. That was the best way of possibly saying it, Skylar, honestly, for the pure average. It's a fair share. You guys have been awesome. Take your sugar back to your seats if you want. Otherwise, give it to somebody else. Otherwise, leave it wherever. Have some sugar. It'll keep you awake for the last 20 minutes or so of class. Yes. Now, who wants to explain to me? Who wants to explain to me why what Skylar just described? Why does that imply the formula that Hattie brought up earlier? Hattie, I'm gonna come back to this. I want to come back to this fair share idea. I'm gonna put it here in quotes. Fair share. Love that. Great phrase, great phrase. The average, also called the mean, technically called the arithmetic mean. The mode is sometimes called an average, as is the median, JC. All these things sometimes conversationally get mixed together as averages. But I want to talk about the average as this particular measurement. It's the measurement you guys have learned your entire lives. The one we're going to talk about a lot in this class is called X with a bar on top of him, cleverly called X bar. It's just what he's called, X bar. What that is the sample mean. The sample mean or the sample average. The average of a sample of numbers, or a sample set of data. If you average it, i.e. use Hattie's formula, add them up, divide by how many you got, you end up with what's the sample average. Now, the formula for that, notice how it's an X with a line over the top. That stands for one number, just one number. The formula, and I'm going to do the best I can to get as many formulas out of this class as I can. One thing I remember from my statistics classes in college was they were inundated with formulas, most of which I tried to memorize and then I lost the understanding of until much, much later. But this one is useful enough, I think, to commit to memory. And we're only going to have like 4 of these over the course of 10 weeks, so I think you can handle it. The way you calculate it, as Hattie described, was you add up, and that's the Greek letter for add a bunch of stuff up. That's capital sigma. Sigma starts with an S, so does sum. This is what's cool. I've learned this over the years of studying mathematics. A lot of the Greek letters you see in mathematics and physics actually come from logical places, like pi for a circle. Pi is called pi because that's the first letter in the word perimeter. And when you think about the value of pi, it's the outside of the circle divided by its diameter, outside being perimeter. We call it circumference, but it used to be called perimeter when they were breaking it down by polygons. So when you think about the letters we see and why we see them, they actually go back to Greek roots, which is actually kind of slick. So anyway, you sum up all of your data, which is usually represented by X's, and then you divide by how many data points you have, which is usually denoted by an N. So each of these X's would have been one of the numbers of lollipops you guys had in your hands. Whether it was 0, 6, 4, 3, 2, whatever it was, one of those X's was you. You add them all up and you divide by N, and you end up with your X bar. How does this accomplish the same thing as what Skylar guided you through up here about 3 minutes ago? And I think somebody in the back actually hit upon how we could have done this differently. It was Kate, it was you. You said it. Why don't you guys just take all of your lollipops, throw them in a pile, and split them up? Because that's what she was doing. Throwing them all in a pile and splitting them up is exactly what this is doing, isn't it? Yeah. Adding all the pops together and then dividing by 10. That's what the formula says to do. But we did it. Did you guys at any point know there were 30 total lollipops while you were doing your exercise? You didn't. You didn't need to, because you got straight to this without having to go through that. Slick. So basically, what the fair share or equal opportunity or however you want to think of it is it's a way of assigning some kind of a grand total of data equally amongst an entire sample. Or later a population, but we'll deal with samples for right now. How's that? Is that fair? And that's what an average is. That's all an average is. Cool? Yeah. Add and divide. Use the formula in good health. The one thing I wanted to make sure was that you all knew what it actually means. Because that's one thing. We go through life blindly applying it without any understanding of why. Now we know. It makes sure that every element of the data set has an equal representation of whatever resource we're talking about. Is this always fair? Is this always fair in your opinion? I don't think so. I don't think so. It's not always fair. For example, people that tell me, you're a bike commuter, you're an idiot, you're going to die. Okay, why am I going to die being a bike commuter? Well, because they say things like, well, 5% of the time people die riding their bike. Time out, that's an average. What that means is when they take all the trips taken by bike and then divide that into all the fatalities that have happened, you get 5%. That's an average. That's an average. Thousands and thousands of trials divided into deaths gives you an average percentage. What it doesn't account for is location. Are you on a road? Are you on a trail? There's all kinds of variables that are not measured for right there. Okay, and that's the problem with averages. Averages are great because they share, because they're fair share. They can be misleading because we miss the forest for the trees, so to speak. So be aware. We'll come back to this one, but when my wife was 4 months pregnant, 5 months pregnant, and they wanted to give her an amnio exam to see if my baby had Down syndrome, I wouldn't let them. And they started quoting all these averages for me. Well, here's the average rate of Downs, and I'm like, I understand what you're saying, but do not put that needle in my wife's belly. And we're going to talk about why as we go through this course. Because the averages didn't apply to us. We were in a different demographic than the averages they were quoting. And that's why averages are great, but they can be misleading if you're not applying them carefully enough. Fair enough? More on the amnio later. We'll talk about that more. It's a very important part of this class, I think. Okay, JC, you said, let's put them all in order. Actually, Andrew, you said put them in order. That was brilliant. And then you guys made a bobcatogram, which was freaking awesome. And then we started chopping. We took off the 0 with the 6, and then a 0 with the 5, and then a 4 with the 1, and then and we eventually got down to the middle, and we used the middle values. That's called the median. Yes, that's called the median. That is called the median. I like to think of this as the geographic middle. The geographic middle of a set of data. So basically, it's the only one I'll actually call the middle of a set of data. It's the middle after arranging data in order. And that's what Andrew took care of for us. He put us in order. And then we just found the middle of the ordered data set. If you find the middle of an unordered data set, it doesn't tell you anything. That just tells you, I mean, it's the geographic middle of a set of data that's shuffled, which is fine. But that's like saying the average card in a deck is the middle one that you pull out. It's kind of dangerous to say that if you've got an entire deck of aces. So, cool? And then finally, Jenny, you gave us this first. You said the one that shows up the most. And that's actually got a word, it's actually got a name, it's called the mode. It's called the mode. And I think, honestly, one of my students last term, or was it 2 terms ago, defined this the best. They called it the mostest. And I thought that was just brilliant. The mostest. What a clever way of thinking about it's a fairly simple computation compared to the rest of them. But what a great the mostest. And somebody brought up 244 last time. Oh yeah, it's the mostest. I'm like, that's awesome. Remember that. Remember nothing I say, but something your classmate said. Perfect. It's the most frequently occurring data point. We had a bunch of them in that last data set. There were like 2 5s, 2 0s, 2 3s, or maybe 2 4s. I can't remember now. But we had a few. You could have more than one, okay? You can have more than one. Those are called multimodal, bimodal, trimodal, quadmodal. You can also have none. I mean, if I gave you guys a bunch of lollipops and it was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's no mode. You all have unique values. So, the mode, unfortunately, is all you can do with certain kinds of data. More of that on Thursday. It's also the only thing you can do with qualitative data, and there's not much more you can do with it besides count. Please, Kate?
I can't remember. So with median, if you have 2 centers, do you just cut it in half?
Hold that thought. Let's get into that question right now, shall we? Kate's got a great question on median, because median, we didn't talk about a formula for this. There is a formula for it. It's not worth doing. So we'll do it kind of. And we'll have technology doing it for us in no time. So I want to get into some data that I collected from you guys on last week, Thursday. Remember I asked you how many keys you had with you? As it turns out, I've switched the classes. So this is actually you guys and this is the other class. So since I made them do that, and I didn't realize till later, I'm going to make you guys use their keys. Sorry. Not that anybody cares. But so here's the deal. We're going to use this as an explanation, okay? And we're going to do your guys' keys first, and then we'll go back up and look at theirs to answer your question. So what I wanted to do is let's identify the measures of center on your key data. Let's identify the measures of center on your key data. I'm going to leave that. I'm going to do this and put it right next to it over there. Here we go. I should put some funding in for 3 cameras. That's just what we need. So, key data. Now, we're going to complete this chart over the course of the next couple days together. We're going to get 2/3 of it done today. The rest there we'll pick up on Thursday. So, we're going to get the average, we're going to get the median, and we're going to get the mode. And we're going to get it 2 different ways. We're going to get it from raw data, and we're going to get it from grouped data. What is this right here? Is it raw or is it grouped? Most definitely raw data. This is what you guys called out to me. You called this out to me in class on Thursday when I said how many keys do you have with you. I said how many zeros, how many ones, how many twos. Okay, so here's your data down here. Pick any of the three measures of center and let me know what its value is. Pick any of the three measures of center and let me know what its value is. Back this up a tiny bit. There we go. All right. What do you think? Which one do you want to do first? Your call. JC, I loved your idea. I think I can use the board to help us do it this way. That's gonna be good. Not everybody at once. Mode! I think mode's great! Why is mode great? Because it's the mostest. Just look for the one that shows up the mostest. Which one is it? I see a lot of twos. Are there more fours? 7 twos. 7 fours. 6 threes. That's pretty slick, actually. So there are 7 fours and 7 twos. Everything else is less than that. So technically the mode, there's 2 modes. A 4 and a 2. Okay? Technically speaking, some statisticians, I'm going to put 2, 4. Because they both occur 7 times. Statisticians would probably also put 3 in there because it's so close to 7. Let's come to an agreement together that it's the most frequently occurring ones. Even if it's off by 1, I don't want to mess with your minds right now. Statistics is hard enough already to process. Let's just make some things concrete. So the mode is the most frequently occurs. Hot damn! Good. Alright. What's next? What are we doing next? Median. Why? Why did I raise the board a little bit? Because JC, come here, grab a pen. Grab a pen. I need your help on this one. Because if I run back and forth, I'm going to trip myself and break my face. We're going to do back and forth and we're going to figure this out. You want to go first or second?
Second.
Nope. Okay. Alright, you ready? I crossed off 0. Okay. 0. Oh, grab one of mine. They should be in this little up here on the gravity clip, except for blue. Blue's dead. There we go. So I crossed off 0 and 0, so you go 8 and 7. Okay, 1, 2, 2, 2, 2. I went first, right?
Yes.
Okay, so keep going. You're doing great. Good. Now, that's the last one. That means he's in the middle. He's in the middle. If I was to put these in one big row, that would be the middle point, right? That means our median's 3. Done. Done. Perfect. Thank you, my friend. Boom. Awesome. Awesome. Median is 3. Is there an easier way to find it than that? Hell yeah, there is. But I want to make sure you can see what JC had done verbally earlier when she was saying cross, 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 cross. That's what you'd actually have to do. So the median is going to be 3. Now, Kate's question is, what if you can't come to one single median value? Like the Monday, Wednesday keys, which are actually your keys, but we're going to pretend they're not. That one, if me and JC had gone through that, what would have happened? Chop, 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 chop. We would have crisscrossed, and then after she went, we would have 5 and 4 uncrossed off, wouldn't we? So what do we do then? We cross them both off into the median 0? You can't do that, because the median isn't 0, the median's in the middle. So what do you do with those 2? You find the middle of those. So if it's a 4 and a 5, you call it 4.5. And that's what they called their median. Or your median, technically. But yes, 4.5 was the median for that data set. So that's how you get around that gate. If you have 2, you just find the middle. Sometimes the 2 are the same number. So it might be like 6 and 6, in which case it's just 6. Not to go to the number of the beast, but I mean, that's what you just do, is you just grab the middle, and it's the same number. But sometimes this happens too.
Even if it's like 10 and 4?
10 and 4, then the average is halfway between, 7. Yeah, I mean, and the smaller a data set, the more likely that is to happen. But, and that's the limitations of using a median on a small data set. Good point, my friend. Cool, we got ourselves a median, we got ourselves a mode. We've been avoiding the average, haven't we? Yes, we have. We've been avoiding the average. Let's drop it back down. Yeah, we could do this the share way, couldn't we? We could do this the share way. We could borrow some of these 8s. Maybe cut the 8 into like 2, 3, and 3, and give some 3s over there. Why don't you guys crunch and I'll crunch and we'll see if we can come up with the same answer. That's 28, right? You got... That is already on it? Fantastic! We have 99 keys. I'm going to trust you, because I'm not going to add it up myself. I was about to, but you saved me the effort, thank you.
Okay.
It's over for Natalie. So the X bar is going to be 99 total keys divided by 30. You guys are amazing. Thank you for doing all my work for me. Divided by 31, which is going to give it, it was 33 to be exactly 3. Is it 3.3, something like that? What do you guys get?
3.19.
3.2. We'll call it 3.2. That's perfect. So I'm glad we didn't do the sharing thing now, right? Because if we were going to do the sharing thing, we'd have to be cutting keys up and getting 0.2 keys to people. Kind of annoying. Notice how they're all kind of similar. 3.2, 3, 2 to 4. Very, very similar values. Very, very similar values. Fair. Some of you have done this before. Obviously, you've heard the fair share before, Scott. Very nice. But some of you have done some of these calculations before. How many of you have taken an average before? Yeah. Done a median before? Okay. Mode? All right, good. So about twice as many of you have done averages have done the other two. Good. Now you know how all three of them work. Or at least how you would do them manually, which you'll probably never do again after this, which is totally fine. Fair enough. Fair enough. So if we all had an even number of keys, 3.2 keys per, that would be the equivalent of if I had like a bin in the back of the room and you all threw your keys into it and you walked in. And it would suck, because then you were never going to get home, right? It would suck. So, now my question is, suppose I give you the data like this. Suppose I give you the data like this. Could you get anything meaningful from this data? Which, FYI, is the exact same data you just got, but now it's what? Exactly. I've turned it into a frequency distribution and given you the histogram or bar graph of that, right? Which means, what have we sacrificed? Yes, we've lost the individual values, haven't we? No longer do we know that there are 2 zeros and however many 1s, however many 2s. All we know now is that there are 12 0 to 2 key holding people. There are, looks like 16 3 to 5 key holding people. And then looks like 3 6 to 8 key holding people. Can we get anything useful from this information whatsoever?
Kind of see the bell curve.
Oh, good, good, good. The bell curve's kind of ish there. I could also tweak the number of categories I have to smooth it out. Maybe if the bell curve actually, just tell me any more time. Michael, thank you. Yes, kind of see the bell curve. And I'm not trying to force bell curves on you guys. Not everything is bell-shaped. This tends to be, actually it tends to be a little skewed. I'll show you that maybe on Thursday. I have a graph of that in here. But my question is this, can we get these three, or at least some of them, from that graph? What do you think? What's your gut tell you? Hattie says yes, my gut says yes. It also says I'm hungry because it's lunchtime. That's okay though. So which one can we get, do you think, my friend?
I would say mean. Probably
Good! How can we do it?
just take the number of values and divide by 3.
But I don't know what the values are.
Well, you know the frequency.
Yes, I do. Very nice. I've got 12, 16, and 3. I love it.
Right? So, based on that number,
I love where you're going with this, Hattie. I love where you're going with this.
my engine is running out again.
Don't you worry about it. I'll tell you what. Shirley, let's take a pause on that one, only because it's going to take more than 3 minutes to explain. And I want to do a good job explaining it because it's the idea of a weighted mean, and it's crucial. So let's pause on that until Thursday. Pick one of the other ones. Pick the easiest one.
Mostest.
The mostest. What's the mostest? 3 to 5 is the mostest, isn't it? 3 to 5 is the mostest. So for the mode down here, you can either put 3 to 5, or what statisticians often do, and we'll use this again on Thursday, is they pick 4. They pick the number in between. And they say, you know what? Honestly, we don't know how many 3s, how many 4s, or how many 5s. But we assume it's evenly split through that range. So, if we've got some 5s, they're going to be offset by the 3s, which averages out to 4. And then the 4 is already in there, so call everything a 4. That's a little bit wishy-washy, isn't it? And that's why I don't want to answer what Cheryl was about to say right now until Thursday. I promise we'll do it Thursday, though. We'll also get the median and the average. I promise. But we can get surprisingly, disturbingly close to the true values from this. Which we will on Thursday. We're going to stop it for a day, though. Let me get some papers back to you guys, though. So no homework.